Okay, so today we're going to work with fractional exponents. So I gave you guys a little taste of this yesterday. We're going to continue it today. And I have a really good analogy for you. So 5x to the 1/3 is like saying, first of all, from yesterday, that denominator means what? What is the denominator in a fractional exponent? Remember from yesterday? It's the index. So this is saying that I've got 5x to the 1/3 one time, or broken up into threes one time. So I'm going to compare it to baking. How many of you have baked? Okay. Many of you have baked. So when you bake with cups, correct? So you get out all your measuring cups. You get out your 1/3 cup, your 1/2 cup, your 1/8 of a cup, your 1/4 of a cup, right? And then your recipe out tells you how many of those cups to use. So that's what we're going to use as an analogy for this. So for instance, this would be saying I've got x. I'm going to use my 1/5 of a cup, right? And I've got that 6 times. I'm going to put 6 of them. Make sense? All right. Now I've got 5k. What kind of cups am I going to be using for 5k? Well, 1/2 of a cup, right? A 1/2 cup, how many 1/2 cups do I need? 5. What about this one? 6k squared to the 1/3. I've got 6k squared, and that's going to be, what type of cups am I using? 1/3 of a cup, so it's going to be a cubed root. You like this? Okay, good. All right, questions on this so far? We did a little bit of this yesterday. Sam?
What happens if it's not
Good question. Okay, so if this wasn't in parentheses, the same thing.
well, I mean, like number 4, 6k squared, what is 6k squared 1/3?
Okay, the difference between that, so you're saying here, let's give ourselves a little bit of space here. You're saying that if it was 6k squared to the 1/3, like this. Okay, the difference, the parentheses, this is a good question. The parentheses tells me not only is k squared 1/3, but so is 6. Without the parentheses, I wouldn't know that 6 is also 1/3. And somebody, I'm surprised nobody asked me this, what's the difference between this one right here and this? True, the placement, but doesn't this mean this many times? Right? So if I were to say that 6 times, well, isn't that the same as me doing this 6 times? They are the same thing. No matter how you put it. This is saying this 6 times, and if I put this in here, that's saying I've got, because couldn't I take this right here and break that up into 6 times? Right? So they are the same thing. Okay. We're going to practice more of that. And I just ruined my line here. All right, let's go the other way, which I think is actually easier. You tell me. So, this is x. What type of cups am I going to use? The 4th cup, right? And how many do I have? 1. This one is, when there's nothing there, it's squared, correct? So what type of cups am I using? Half cups. And how many do I have? 5. What about this one? This one would be easier with parentheses, right? I've got 10x. Be careful with this because both 10 and x are affected by this fractional exponent, right? What type of cups am I using? Thirds. And how many do I have? 2. And finally this one, 10x squared to the what? 1/6. Okay, make sure you have that written down. Okay, so I will be able to simplify fractional exponents. So we're going to do what we were just doing right now. We're just going to take it a little bit of a step further. All right, fractional exponents, pencils down. I'm going to do 4. You're going to copy them down when I'm done. Then I'm going to give you 4 more, and you're going to do those. Okay? And that's all we've got today. All right? Okay, so everybody's attention. 3b to the 5/3 times 2b to the 4/3. I am. Thank you for reminding me, though. So I know that 3 and 2 are not involved in these fractional exponents, right? There's no parentheses around them. So I can use the commutative property to kind of move things around here. So I have, let me change my color. I have 3 times 2 times b to the 5/3 times b to the 4/3. Now let's put a little side note over here. If I had x to the 3rd times x to the 3rd times x to the 3rd, how many x's do I really have? I have 3 plus 3 plus 3, right? X times itself 9 times. So I have the same thing here. As long as I've got common denominators and common bases, I can add these 2 fractions. So I've got 5/3 and 4/3, so I really have a total of, oops, not 6. I'm writing way too small. Let me write a little bit bigger. 6b to 9/3. But isn't 9/3 3? So the answer to this is 6b cubed. Questions on that one? Following so far? Okay, let's do this one. Well, I'm going to do this one. So I've got 3 and 4. So 3 times 4. I've got x to the -1/2. I've got x to the 1. And I've got x to the 1/2 over here. Isn't a -1/2 and a +1/2 0? So I have none. 12x. Here's another one. Okay, same as the last ones that you did on the homework. It's one of those things where you just got to practice it, Sam. This -1/2 and +1/2 is x to the 0. Anything to the 0 is 1. Got it?
Yeah.
Okay. So this is 4 times 2. I'm just going to say which is 8. And n squared times n to the 4/3. All right, that doesn't help us too much. You have to find a common denominator. How could I change 2 so that it's in thirds? 6 over 3 is 2. Correct? Whoops, it's not the 8. I need the n in there. So 8 times n to the 6/3 times n to the 4/3. Everybody understand that so far? So now I have 8 to the n. 6 plus 4 is 10/3. Last one. I'm going to go ahead and erase this while I remember. If it tells you to put it into, keep it in fractional exponents. Okay, so last one. I've got negative exponents. I've got uncommon denominators. So the first thing I need to do is, it's kind of like working from the inside out. Okay, let's deal with the uncommon denominators first, and then we'll deal with the negative exponents last. Okay? So what I'm going to do is I'm going to say I've got a 3. I'm going to start it over here and then work my way down. I've got a 3 times x. This is a third. I want to make this a third. So I'm just going to say negative 6/3. I don't know why I chose to put that so far over. I'll just leave it. Times x to the negative 4/3. All right, that equals 3 times, you'll see it's why I'm fidgeting so much right now in just a second. 3 times x to the negative 6/3 negative 10/3. Okay, from here, we can't have negative exponents. So negative exponents are what? Positive fractions, correct? So I'm going to start this here and make 3 in my numerator. And if I put x to the negative 10/3 in the denominator, the inverse of the numerator, I can change it from a negative to a positive, correct? So I'm going to put it down here, and it's now positive 10/3, which poses a problem. Why does this pose a problem? You can't have a fraction in the denominator, but more specifically, you can't have a radical in the denominator, and this is really a radical in fraction form. So I'm going to change it into radical form first, if that's okay with you. This is, what's my index? 3. And I've got x to the 10th, correct? How many more x's do I need to get that x out of there? Good. Those of you who said 2 did your homework, right? Because that was your homework last night. Okay. So I need to multiply by 2. I need 2 more, because if I had 2 more, I'd have x to the 12th, and that's divisible by 3, right? Okay, so now this part is review. So I have 3. I can't simplify this at all, right? Cubed root x squared all over, I'm not going to skip a step this time, x to the 12th, or how about x cubed times x cubed times x cubed times x cubed. I've got 12 of them, which leaves me with 3 cubed root x squared all over. How many get kicked out? 4, and that's your answer. All right, so go ahead and write all 4 of these down, and then we're going to practice 4 just like them. Yes, Jacob?
You're getting the radical out of the bottom, out of the denominator. Multiply the whole thing by, like, on that one, multiply the whole thing by root of x. Okay.
No. Okay, if I would have multiplied the whole thing, this is a really good question, because that's what we're used to doing, right? Just multiply it by the same thing and it comes out. I could have if it was a square root, but I can't, because if I multiply that by that, you know how many I get?
Um,
I get 20. And is 20 going to give you, you need 21, right? Make sense? Give you guys a second to copy all that down. Okay, let's also add some steps to this. Now that you guys have written that down. Let's put our steps up here. So, number one, you need common bases. Number two, you also need common what? Denominators. What would be our third step? We need common bases, we need common denominators. I don't know if we want to actually, you have to combine like terms or you're adding the fractions. I think the next thing you need to consider, I guess there are not as much steps as considerations. Common bases is your first consideration. Common denominators is your second. The fact that you don't want negative exponents, no negative exponents. And then finally, you don't want fractions in the denominator. Make sense? Give you guys a second to write that down. All right, so let's move on. You guys try number 5. Okay, so I don't think I need to do this one in front of you. You tell me, did you get 4p to the 7/2?
Yeah.
Excellent. Ready for 6? Okay, try 6. All right, so did you guys get 4b to the 1/3? Do I need to do this one? 2/3 minus 1/3 is 1/3. Okay, try this one. Okay, so this one is 2 times 2 times x to the 1/4 times x to the 8/4, thank you, which is 4x to the 9/4. Now you guys do this one. All right, let's do this one together. So I've got 4 times 3. I'm going to kind of go this way. 4 times 3 times n to the negative 3/4 times n to the negative, let's change 1/2 to 2/4, which equals 12 to the n. Negative 3/4 and negative 2/4 is negative, just kidding, 5/4. I've got a negative exponent, which is positive fraction, so I'm going to say 12 divided by, can I just turn that right into a square root?
Yeah.
I have n to the 4th, my index is 4, because I'm using 4th cups, that's what we're concentrating on, and I have 5 of them. How many more n's would I need before I've got n to something that is divisible by 4? I need 3 more. So I'm going to multiply by n cubed to the 4th root. N cubed to the 4th root. Which gives me 12 4th root n cubed divided by, if I have n to the 5th times n cubed, I now have n to the 8th, 4th root. How many n's get kicked out? 2. So my final answer is 12 4th root n cubed all over n squared. Questions? Jacob.
The denominator is where the, okay,
You got it? You sure? Can I go? Fantastic. All right, what did you learn today? We call these fractional exponents. Pause, guys. I'm putting the pause on you. Please pay attention. The denominator of a fractional exponent is the what? The index. Good. On your assignment sheet, the denominator cannot contain any what? Negative exponent. I'm sorry? Or radicals. What else can the denominator not contain? Fractions, radicals, 0, I, all those things? Okay, great job, guys. We had it on the first screen. I'll print it up right now. Okay. Homework time.